Today we are going to see some important points from your flow of fluids. So as yesterday I have told you, there are certain topics remaining from pharmaceutical engineering, and one of that topic is flow of fluid. So today we'll see the important points flow of fluid. Then whatever are the main points that can be asked in the exam, we are going to highlight only those points. I'm not going to teach you whole chapter as like your regular teachers they used to teach you for semester exam. I'm not going to teach you in that manner. I'm just going to highlight important points for GPAT Niper and other exams. So what do you mean by flow of fluid and why you have to study this flow of fluid? So you need to understand this. So you are working in the pharmaceutical industry, you are handling different kind of material. Okay, you are handling some kind of solids, you are handling some kind of liquids over there in the industry. So you need to understand flow of same. Okay, suppose that you are engaged in the manufacturing of your lipid orals. You are engaged in the manufacturing of suspension, emulsions, syrups, etc., etc. So in that case, you have to handle these liquids. You have to handle the water. You have to handle the solvent, glycerin, isopropyl alcohol, and all that. Okay, so you need to understand the behavior of that liquid. Okay, so you are mixing those kind of liquids. Okay, you are storing in the storage tanks, and then you are transporting that liquid into your filling machine. Okay, through the pipes using various kind of motors and pumps. Okay, during the transportation, during the mixing, during the handling, you have to observe. You should keep in mind what type of flow is there, what type of flow is there with that respect to that whatever mixture you are using. Then you need to understand the flow of fluid for mixing as well as transportation of fluid as well as handling of liquids. So now these flow of fluid, that is nothing but the there are two types of flow: static, fluid static, and fluid dynamic. So if fluid is on the rest, that is known as a fluid static. And if fluid is moving, or suppose that fluid is in a motion, that is known as a fluid dynamics. So these chapters, they are divided into fluid static as well as fluid dynamics. Okay, now suppose that you have one liquid which is a static in nature. It is a it is on a rest. Okay, and suppose that fluid is in a tank. This one is a tank. Suppose that this one is a tank, and you have a fluid or liquid in the tank. Basically, fluid means what? Fluid means a solid particle in the air stream, that is known as a fluid. Okay, fluidized state, or simple liquid in a motion, that is also known as a fluid. Liquid in a motion means liquid along with the air. Okay, liquid along with the air, that is also a fluid state. Then solid in the air, also a fluid state. So that is a fluid. Suppose that you have one liquid. Okay, you are stored in the tank. Okay, this is your tank, and you have two openings over here. First opening will be here. Okay, and second opening will be here. The flow from this point, flow of liquid from this point will be different, and flow of liquid from this point will be different. So flow of liquid from this point will be with the additional pressure. Flow at this point will be at lower pressure. So why this is happening? Because see, so atmospheric pressure is there. So atmospheric pressure is there at this point. So at this point, the atmospheric pressure is less. At this point, atmospheric pressure is more. So that's why this the liquid coming out from point number two, that is under the pressure. There is a difference in the pressure. Okay, both points. So point number one, the liquid which is as point number one will have a different pressure, and liquid which is point number two will have a different pressure due to difference in the height where they are placed. Okay, so at this point, liquid will experience little bit different atmospheric pressure, and at this point, liquid will experience different atmospheric pressure. That's why the liquid, whatever is coming out from this point and this point, will have a different pressure. So relatively, liquid coming out from this point will have a higher pressure as compared to, so suppose that this is the point 1 and this is the point 2, point 1 and point 2. So whatever pressure exerted by atmosphere on the liquid, suppose that this is the pressure Ps. Okay, now pressure at this point, pressure of liquid at this point, pressure of liquid at this point will be different because they have different heights. They have different heights. Now pressure difference between point 1 and point 2 can be calculated by measuring the difference in the height, that is delta H. Pressure between these 2 points can be measured by just measuring the height of that difference in the height, delta H. So that is a hydrostatic pressure. So pressure exerted by liquid, that is nothing but the hydrostatic pressure of pressure exerted by water, hydrostatic pressure, that can be measured. Okay, so this hydrostatic pressure will have different for point 1 and point 2. So ये जो point है, ये point के यहाँ पे hydrostatic pressure कम होगा, ये जो point है यहाँ पे hydrostatic pressure ज़्यादा होगा. Now the pressure differential you can measure by just measuring the difference in the height, that is delta H, and this is the principle involved in the measurement of pressure differential by using manometers. So the apparatus or the instrument used to measure the pressure differential is nothing but the manometers. Okay, there are different kind of manometers. We'll see it in the upcoming slide. These are the, so first we'll see what is meant by flow of fluid. So fluid flow may be defined as the flow of substances that do not permanently resist the distortion. This is a standard definition. Okay, flow of fluid means fluid in the motion. So it is defined as the flow of substances that do not permanently resist the distortion. Suppose that आपके पास एक लिक्विड है और आपने उसमें स्ट्रेस डाल दिया, आपने उसमें कुछ मूव करने के लिए उसमें फोर्स डाल दिया. स्ट्रेस मतलब फोर्स. So if you apply stress to a liquid or to a fluid, okay, so there will be distortion, there will be change in the shape of that fluid, okay, initially, and then uh, that liquid, because of that applied force or stress, it will gain another shape, okay, and after that it will gain another shape, okay. So by virtue of this pressure, virtue of this pressure or stress, it will be displaced. So that is in a fluid, that is in a flow, that is nothing but the flow. So in the standard word, flow is nothing but the flow of substances that do not permanently resist the distortion. There is a flow of fluids. Now these fluids may be either static or dynamic. Now fluid static means what? So it deals with the uh, fluid at a rest or equilibrium. Fluid static means deals with the fluid at the rest or equilibrium. जहाँ पे कोई मूवमेंट नहीं हो रहा, वहाँ पे कोई मोशन नहीं, एक मतलब मान लीजिए आपके पास एक टैंक है और उसमें वाटर है, so that water is in a static, so that fluid is in a static. So fluid static means deals with the fluid at the rest in an equilibrium. Now what is fluid dynamics? So fluid dynamics means fluid in the motion. Suppose that same water is flowing through one pipeline, so that is nothing but the fluid in dynamic. अगर आपके पास वाटर है टंकी में और वहाँ पे रखा है, वहाँ पे तो उसको बोलेंगे फ्लूइड स्टैटिक. ओके, अगर वही वाटर आप पंप के थ्रू आप दूसरी जगह पे लेके जा रहे हो पंपिंग के थ्रू, सो while passing in the pipe, that fluid is in a motion. So fluid static and fluid dynamic, these are two terms. Now next, manometer. Manometer is nothing but it is a device, it is the apparatus used for measuring the pressure difference. Okay, as I have told you, at a different point, the fluid will have different pressure. That pressure can be measured by one device known as a manometer. A manometer works on the principle as I have told. So these manometers are classified into three different ways, three different types. Sorry, these manometers are classified into three different types: simple manometers, then simple manometer, okay, then so simple manometer, then inclined manometer. These are the three different types of manometers. I will explain this. So first one is a simple manometer. So remember, simple manometer, they are most commonly used, and they consist of a glass U-shaped tube. Glass U-shaped tube. So glass U tube filled with the two different liquids. Okay, so liquid A and liquid B. So they may have a different densities. They may have a different densities. So it is a simple manometer, and they will have two immiscible liquids. Those liquids will be immiscible. सिंपल मैनोमीटर क्या होता है कि एक यू ट्यूब जैसा ग्लास ट्यूब होता है, यू शेप्ड ग्लास ट्यूब होता है, और उसमें जो आर्म्स होते हैं, दोनों आर्म्स, ठीक है, उसमें क्या रहेगा कि आपका मिक्सचर रहेगा लिक्विड का, इमिसिबल मिक्सचर विथ अ डिफरेंट डेंसिटी एंड दे आर इमिसिबल, ठीक है। जैसे मर्क्यूरी हो गया, वाटर हो गया, दोनों को साथ में यूज करेंगे, वाटर मर्क्यूरी इमिसिबल लिक्विड्स, ठीक है, सिंपल मैनोमीटर। दूसरा होता है डिफरेंशियल मैनोमीटर। एक टाइप का होता है आपका सिंपल मैनोमीटर, फर्स्ट टाइप ऑफ मैनोमीटर इज सिंपल मैनोमीटर, दूसरा होता है आपका डिफरेंशियल मैनोमीटर, तीसरा होता है आपका इंक्लाइंड मैनोमीटर। सो देयर आर थ्री टाइप्स ऑफ मैनोमीटर, रिमेंबर। नाउ इन केस ऑफ सिंपल मैनोमीटर, इफ यू वांट टू मेजर अ हाई प्रेशर डिफरेंस, अगर आपको प्रेशर डिफरेंस ज़्यादा है, वहाँ पे हाई प्रेशर डिफरेंस है, इफ यू वांट टू मेजर हाई प्रेशर difference using simple manometer, then mercury is used. Okay, mercury is used as a liquid for manometer. So mercury is used as a liquid in a manometric liquid. Mercury is used as a manometric liquid when pressure differential is high. ठीक है, इसके ऊपर क्वेश्चन आ सकता है, इसके ऊपर ऑलरेडी क्वेश्चन आ चुका है। the device used for measuring the pressure difference is nothing but the manometer. Manometer क्या है? Device used to measure the pressure differential. ये क्वेश्चन आ चुका है ऑलरेडी। Now, if you want to measure a high pressure differential, if you want to measure a high difference in the pressure, then what kind of manometric liquid is used? So that is mercury. ठीक है, मैनोमीटर कितने टाइप होते हैं? So manometer is a apparatus or device used to measure the pressure difference. ठीक है, then they are classified into three classes. First one is a simple manometer, second one is a differential manometer, and third one is a inclined manometer. So out of that, simple manometer and differential manometers, they are used. Out of that also simple manometer are most commonly used. सिंपल मैनोमीटर ज़्यादा यूज किए जाते हैं, डिफरेंशियल मैनोमीटर थोड़ा सा उसका यूज कम है, बिकॉज दैट इज मोर प्रिसाइज एंड दे डिफरेंशियल मैनोमीटर इज यूज टू मेजर द स्मॉल प्रेशर डिफरेंशियल। सो सिंपल मैनोमीटर में क्या होता है कि यू शेप्ड ग्लास ट्यूब होता है, क्या होता है इसमें, यू शेप्ड ग्लास ट्यूब विथ टू डिफरेंट लिक्विड, two different immiscible liquid with different densities. And in case of high pressure difference, if you want to measure high pressure difference, mercury is used as a manometric liquid. And if you want to measure a low pressure difference, then alcohol, water, carbon tetrachloride can be used as a manometric liquid. Then another type of okay, so these are the this is a simple manometer. So what is the application of this simple manometer? इसके एप्लीकेशन क्या रहेंगे? ऑब्वियसली द मैनोमीटर इज द डिवाइस यूज टू मेजर द प्रेशर डिफरेंशियल। तो प्रेशर डिफरेंस कितना है, प्रेशर मेजर करने के लिए उसका यूज होता है, तो उसका एप्लीकेशन क्या रहेगा? तो ऑब्वियसली सो फर्स्ट एप्लीकेशन में मेजरिंग द कंजम्पशन ऑफ गैसेस इन द केमिकल रिएक्शन। ठीक है, मेजरमेंट ऑफ कंजम्पशन ऑफ गैसेस इन द केमिकल रिएक्शन। तो आप बोल रहे कि सर ये कुछ समझ में नहीं आ रहा है, कैसे ये गैसेस का और इसका क्या संबंध? मेजरिंग द कंजम्पशन ऑफ गैसेस इन द केमिकल रिएक्शन। मान लीजिए आपका इंडस्ट्री है, मानने में क्या हर्ज है, ठीक है, इंडस्ट्री है और आपके वहाँ पे एक रिएक्टर लगा है, तो वहाँ पे एक रिएक्शन चल रहा है, तो वहाँ पे आप क्लोरीन का गैस इंट्रोड्यूस कर रहे हो एट अ कंट्रोल रेट, कि पर्टिकुलर रेट से क्लोरीन का गैस एंटर कर रहे हो रिएक्शन। सो टू मेजर द फ्लो ऑफ दैट गैस you need a manometer. To measure the pressure differential you need a manometer. Okay, so measuring the consumption of gases in the chemical reaction, then these manometer along with the flow meters, these manometers along with the flow meters, they are used to measure the flow. Manometers along with the flow meters, they are used to measure the fluid flow. Okay, suppose for example venturimeter is there, orifice meter is there, so they are the meters used to measure the flow of fluid. Okay, venturimeter, orifice meter measuring the flow, they are used to measure the pressure head using manometer. Then again pitot tube is used to measure the velocity of velocity head using manometer. So manometer इनके साथ में combine करके यूज करते हैं। These venturimeter, orifice meter, Spider tube, they are used to measure the flow of liquid or flow of fluid. Along with that, manometer are used. Now, second class of manometer are nothing but the differential manometer. So, obviously, if you want to read the construction of this simple manometer and construction, working, and all that derivation, you can read from books. But because the construction and working and all that, that is not important for you GPAT. GPAT के लिए क्या important है? What is simple manometer? Okay, उसमें क्या होता है? उसका यूज क्या है और एप्लीकेशन क्या है, दैट्स इट. ओके, सो दैट इज इंपॉर्टेंट फॉर यू जीपैट नाइपर एग्जाम. ओके, सो यू कैन एक्सपेक्ट ओनली वन और टू क्वेश्चन फ्रॉम दिस चैप्टर. ऑलरेडी उसके ऊपर पर सिर्फ दो बार ही क्वेश्चन आ चुका है और दो टाइप का क्वेश्चन आ चुका है. नाउ सेकंड इज नथिंग बट द डिफरेंशियल मैनोमीटर. तो डिफरेंशियल मैनोमीटर मींस it is used to measure a small pressure difference. It is having sensitive devices and used for measurement of small pressure difference. It is also known as two fluid U-tube manometer. Two fluid U-tube manometer. So differential manometer is also known as two fluid U-tube manometer. ये याद रखो. And same thing, इसमें भी क्या होगा, U shaped का एक ग्लास ट्यूब होगा और उसमें टू इमिसिबल क्या रहेंगे, लिक्विड रहेंगे, but they are having nearly same density. Occasionally these differential manometers they are used occasionally. तो उसका यूज क्या है, occasionally. Most commonly used कौन सा होता है, simple manometer. So these differential manometers are occasionally used and they are suitable for measuring the small pressure differences. They are having sensitive devices and they are useful for only measuring the small pressure aids, okay, measuring the even small gas pressure. So this is the differential manometer. Then third type is inclined manometer. Inclined manometers are also there. They are having very limited applications, so they have not discussed over here. So you just remember there are three kind of manometers. That is nothing but the simple manometer, then differential manometer, inclined manometer. तो क्लासिफिकेशन याद रखो यहाँ पे, सिंपल, इंक्लाइंड, डिफरेंशियल, ये तीन टाइप का आपको मैनोमीटर होता है. सिंपल मैनोमीटर इज द मोस्ट कॉमनली यूज. डिफरेंशियल मैनोमीटर इज आल्सो नोन एज टू फ्लूइड यूट्यूब मैनोमीटर. याद रखो, इट इज यूज फॉर मेजरिंग द स्मॉल प्रेशर डिफरेंशियल. क्वेश्चन आपको ऐसा आ सकता है, वन ऑफ द फॉलोइंग टाइप ऑफ मैनोमीटर is used to measure a small pressure differential. So differential manometer, not a simple manometer. तो आप ऑप्शन में देंगे आपको simple manometer, differential manometer and inclined. तो याद रखो. And most commonly used कौन सा होता है, simple manometer. Now you can see over here. So this one is known as a simple manometer. This one is known as a simple manometer. First one is a simple manometer. So here liquid A is there. So these are having difference in the densities. इनके लेवल में difference है density. मान लीजिए कि यहाँ पे एक प्रेशर आपने यहाँ पे अगर प्रेशर अप्लाई किया है पर्टिकुलर, तो क्या होगा, बिकॉज ऑफ द ड्यू टू डिफरेंस इन द डेंसिटी these arms will have different pressure, and this pressure can be measured by simple manometer. Now a differential manometer will look like this. Construction of differential manometer is like this. बाद में आप, if you want to read, you can read full construction, working and derivation and all that. That is not important for those GPAT exam. GPAT exam के लिए जो है वो. Now second important point is the Reynolds experiment. Suppose that you have a liquid. Suppose that you have a liquid in a tank. Let's say water in a tank, and that is connected to a glass tube. ये क्या है, पूरा ये glass tube है, glass tube. Now this water is connected to a glass tube via valve. Valve means you can control the flow of water using valve. So valves are used to control the flow of liquid or flow of fluid. Okay, valves. Okay, and at the another end, you have a different colored liquid over here. That liquid is also connected to that cluster through a nozzle. Okay. Now suppose that your water is flowing slowly. Means your water is having less velocity. Water is flowing slowly. Okay, and this colored solution is also introduced. When the flow of water is low or the velocity of water is less, at that time you will observe a thin line of this colored solution, or thin line, or a stream of line of this color solution when there is a low velocity of water. At the low velocity, when water is introduced at a low velocity, means the flow of water is less. Okay, at that time you will find a a simple streamline of that colored solution, or a one thread like colored solution. You can easily say when this colored solution and water is not mixed, when the flow is less or the velocity of water is less, this colored solution will not get mixed up with the water, and this kind of flow is known as a streamline flow or viscous flow or laminar flow. Okay, so this kind of flow is known as a streamline flow or viscous flow or laminar flow. Okay, when at a low velocity, if you introduce water into this glass tube at a low velocity, the colored solution will not get disturbed. Okay, so there will not be interaction between that color solution and water. So that color solution will be you cannot easily observe that color solution is flowing through a simple parallel line. Okay, or simple one jet line, color liquid jet. Okay, or stream, jet or stream, that is same term. Okay, at the low velocity. So this type of flow is known as a laminar flow, or it is known as a viscous flow, or it is known as a streamline flow. Okay, all these are the terms same. These are the synonyms: streamline flow, viscous flow, or laminar flow. So at the low velocity you will get a laminar flow. At that laminar flow, this colored liquid will slide to a layer of each other. ठीक है, जैसे स्लाइड करके जा रहा है वो, उसको कोई डिस्टर्ब नहीं कर. So that is a streamline flow or laminar flow or viscous flow. But if you increase the velocity of water, or if you increase the rate of introduction of water, if you increase the flow, जैसे आपने वाटर का फ्लो यहाँ से इंक्रीज कर दिया, ये फ्लो अगर आपने इंक्रीज कर दिया, so what will happen? So the water will be introduced into this glass tube at a higher flow rate. At that time, what will happen? So this colored solution जो है आपका, whatever the color solution, so that will get disturbed. Okay, that color solution will get some mix up. So water and colored solution will get mix up because due to eddies diffusion at a higher flow rate. Because of eddies diffusion, and there is an interaction, there will be a strong interaction between water introduced and the color solution, and water will get colored. Water will get colored. Now this type of flow is known as a turbulent flow. This type of flow is known as a turbulent flow. So at a lower rate, when you introduce a lower rate, water is introduced at a lower velocity or lower rate, you will observe a straight line of that color solution. So there will be no physical mixing of that your water and your color. So that is known as that type of flow is known as a laminar flow or streamline flow or viscous flow. And if you introduce that water with a higher rates, so there will be mixing of your color solution and water, and you will get a this type of flow known as a turbulent flow. Okay? That is the main basic difference. ठीक है, turbulent flow क्या होता है और laminar flow क्या होता है, ये समझ में आ गया आपको. Okay, this was observed by, this experiment was done by Reynolds, and that is known as the Reynolds experiment. So now what is meant by laminar flow or viscous flow or streamline flow? The flow at which fluid particles moves in a layer or lamina, or one layer sliding over each other. That flow is known as a laminar flow. Now, what is meant by this, that turbulent flow? Turbulent flow. At a certain velocity range, if you increase the velocity, the flow will not remain as a steady. Will not remain as a steady, and therefore, because of the eddies current or eddies diffusion, that will be affected, and fluid particle gets disturbed and get mixed up with each other. Two fluids, okay, two fluids particle get mixed up with each other, and there is a continuous transfer of momentum of adjacent layer, and such diffused flow diffused flow is known as a turbulent flow. Okay? So there are two kind of flow, laminar flow and turbulent flow, which was observed by Reynolds after its experiment. Variation in the velocity across the cross section of pipe. जैसे आप पाइप से जा रहा है, फ्लो हो रहा है, so liquid is flowing through in the pipe. So variation in the velocity, वो पाइप में velocity fluid का अलग अलग होता है. जैसे in the middle of the pipe, so there is a different velocity at the edge of the pipe, जहाँ पे पाइप और लिक्विड का जहाँ पे फ्रिक्शन हो रहा है वहाँ पे वेलोसिटी कम होता है, और जो मीन है मतलब जो सेंटर है, सेंटर में वेलोसिटी ज़्यादा होता है. So if you plot a local velocity of fluid against the distance from the uh, wall of the pipe, you will draw some conclusion. You will find some conclusion. Now, what are these conclusion? So flow, okay. So flow at the middle of pipe is faster than the wall near to the pipe. The flow in the middle of pipe is a faster then flow near to the pipe. Okay, the velocity of fluid reaches to a zero as pipe wall is approached. ठीक है, जैसे मिडल में सेंटर में अगर फ्लूइड है तो वहां पे वेलोसिटी ज़्यादा होगा और जहाँ पे पाइप का आपको पाइप का जो सरफेस है सो वो पाइप के सरफेस के वहां पे फ्लूइड का वेलोसिटी कम होगा एंड जैसे ही वो सरफेस जितना ज़्यादा नज़दीक आ जाएगा तो वहां पे वेलोसिटी क्या रहेगा जीरो रहेगा flow of flow in the middle of pipe is faster than the fluid flow near to the wall of pipe. The velocity of fluid reaches to zero as the pipe wall is approached. At the actual surface of pipe, at the actual surface of pipe wall, the velocity of fluid is a zero. Okay, so that is the difference. So variation in the fluid velocity. That is a variation in the fluid velocity across the cross section of pipe. In the in the in the viscous in the viscous condition means in the viscous flow or in the laminar flow or in the streamline flow the velocity over cross section area of pipe is 0.5%, 0.5 times more than 0.5 times of maximum velocity in the viscous flow or in the streamline flow. ठीक है, laminar flow में क्या हो रहा है average velocity over the cross section of the pipe is 0.5 times maximum 0.5 times as that of the maximum velocity. Okay, and in case of turbulent flow the average velocity over the cross section or cross section of the pipe is a 0.8 times more 0.8 times of the maximum velocity. That means turbulent flow में देखो velocity ज़्यादा है और viscous flow में या फिर streamline flow या फिर laminar flow में क्या आता है velocity कम होता है. ठीक है, critical velocity. So critical velocity means that is the average velocity of any fluid at which fluid flow changes into turbulent flow. It is nothing but the average velocity of any fluid at which laminar flow changes into turbulent flow. तो जो velocity है the average velocity of any fluid at which viscous flow or streamline flow or laminar flow changes into turbulent flow, that is known as the critical velocity. These are the terms they can ask you in the exam. That's why I have listed these terms. Change over flow from viscous to turbulent is nothing but the critical factor. So change over of the flow from viscous or from laminar or from streamline to turbulent is known as a viscous factor, is known as a critical factor. Now Reynolds number. Reynolds number is defined as Re is equal to D micro rho divided by again rho. So Reynolds number क्या आता है देखो यहाँ पे D micro rho divided by ये दूसरा एक रो है. Okay, so out of that what is D? D is nothing but the diameter of pipe. D is nothing but the diameter of pipe. Then this micro term, this D is the diameter of pipe. This this micro is nothing but the velocity, and this rho is nothing but the this density of liquid. Okay, this micro is the velocity of liquid, then this is the density of liquid divided by this viscosity of liquid, that is the Reynolds number. Okay, Reynolds number. So you can other way in other terms you can say that Reynolds number is equal to Re is equal to inertial forces divided by viscous forces. Now inertial forces means what? Mass into acceleration, mass into acceleration of liquid. लिक्विड का मास, लिक्विड को भी मास होता है, उसके बाद उसका एक्सेलरेशन, दैट विल गिव यू इनर्शियल फोर्स डिवाइड बाय विस्कस फोर्स. विस्कस फोर्स इज इक्वल टू shear stress into area, that is the viscous force. So Reynolds number is nothing but the inertial forces divided by viscous force. Okay, Reynolds number will give you the type of flow. Reynolds number will give you the type of flow, which kind of flow is there, whether it is a turbulent flow or whether it is a streamline laminar flow. So that you will get idea from Reynolds number. Okay, so this Reynolds equation, just remember this Reynolds equation. You can see there is certain using Reynolds number you can say what kind of flow is there. So this chart is again very important. इसके ऊपर already question आ चुका है. Reynolds number is in a particular range. What will be the type of flow? And Reynolds number is in this range. What will be the type of flow? Okay. So remember this: when Reynolds number is less than 2000, when Reynolds number is less than 2000, RE is less than 2000, the type of flow is laminar. Type of flow is laminar, or it is also known as viscous, or it is also known as a streamline. When the Reynolds number is less than 2000, the flow is laminar or viscous or streamline. When Reynolds number is more than 4000, the type of flow is a turbulent type of flow. And when Reynolds number is between these 2000 to 4000, that means the flow is changing from laminar to turbulent. इसके ऊपर क्वेश्चन आ चुका है. दिस चार्ट इज अगेन वेरी इंपॉर्टेंट. मैंने बोला था ना आपको, इस चैप्टर में दो टाइप का क्वेश्चन आ चुका है ऑलरेडी. The device used for the measuring the pressure differential GPAT 20 one GPAT 2021 में क्वेश्चन आया था. Then Reynolds number, if Reynolds number is less than 200, what type of flow is there? If Reynolds number is more than 4000, what type of flow is there? And this, if Reynolds number is between these, what type of flow is there? So ये GPAT 2018 में भी आ चुका है और GPAT 2021 में भी आ चुका है. So this chart is again very important. एक सिंपल है, अगर 2000 से कम है, if Reynolds number is less than 2000, laminar flow is there, streamline flow is there, और viscous flow is there. तो velocity अगर कम है तो Reynolds number भी कम रहेगा. अगर Reynolds number कम है तो streamline flow या फिर viscous flow या फिर आपका laminar flow है. अगर ज़्यादा है नंबर more than 4000, that is a turbulent. Okay, in between changing the from streamline to turbulent. So this Reynolds number is having no unit. Reynolds number is a unitless. Remember. Now, what is the application of a Reynolds number? To predict the nature of flow, whether it is a streamline flow, whether it is a turbulent. So you can predict the nature of flow using this Reynolds number. Then physical stability of suspension and emulsion. So what is suspension? Suspension in suspension. What is suspension? So there is a dispersion of solid particles in the liquid, that is the suspension. So as there is a solid particle in the liquid, there may be settling of that solid particle. There is a settling of solid particle at the specific time, or that depends on the many factors: temperature, pH, viscosity and all that. But there is settling. Settling means there is a movement. So the velocity at which particle gets settled, the velocity at which particle gets settled, so that can be utilized for the determining the stability of suspension, stability of emulsion. In case of emulsion, globules, rate of settling of globules. When the Reynolds number is applied, for the Stokes, you can get some idea regarding the physical stability and suspension of emulsion. Okay, तो उसके लिए भी यूज हुए. Then for the rate for the calculating the rate of heat transfer. So these are the applications of Reynolds number. Predict the type of flow, physical stability of suspension emulsion, and for the heat transfer. There is another theorem in this chapter known as the Bernoulli's theorem. When the principle of conservation of energy is applied to flow of fluid, you will get an equation known as a Bernoulli's equation or Bernoulli's theorem. So Bernoulli's theorem, what it states? It states that the steady state ideal flow of incompressible liquid. Okay. Steady state of ideal flow. Okay. Bernoulli's theorem states that the steady state ideal flow, steady state ideal flow of incompressible fluid, the total energy per unit mass, which consists of kinetic energy, then datum energy at any point, will remain constant. मतलब ये बर्नौली थ्योरम का हिंदी में बोला तो उसका कहने का मतलब ये है कि अगर आप एक फ्लूइड स्टैटिक है, स्टेडी स्टेट है, तो उसमें जो एनर्जी है एट अ पॉइंट ए एंड पॉइंट बी विल बी द कांस्टेंट, ऐसा कहने का उसका मतलब. सो दैट स्टेटमेंट क्या है? बर्नौलीज थ्योरम स्टेट दैट steady state ideal flow, or a steady state ideal flow of an incompressible fluid, the total energy per unit mass, which consists of pressure energy, kinetic energy and datum energy at any point of fluid, will remain constant. That is a Bernoulli's theorem. So ये statement याद रखो. इसके accordingly क्या है कि incompressible in a steady state, in a steady state, ideal flow of incompressible fluid, the total energy per unit mass will remain constant at any point. That is the Bernoulli's theorem. You can see over here. तो suppose that आपके पास में यहाँ पे liquid है, एक point हो गया point A, ये हो गया point B. यहाँ से आप liquid को move कर रहे हो यहाँ तक by using a pump. So pump is used to increase the kinetic energy of liquid. Okay? Liquid का kinetic energy वो बढ़ा देगा by using. ठीक है? According to Bernoulli's theorem क्या बोलता है कि यहाँ पे जो उसका एनर्जी है और यहाँ पे जो एनर्जी है वो कांस्टेंट होना चाहिए, वो कांस्टेंट होना चाहिए. That should be constant. Okay, so the energy per unit mass of a fluid will be constant at any point. That is the Bernoulli's theorem. But ठीक है, so energy means what? Energy is composed, total energy is composed of your pressure energy, then kinetic energy, and datum energy. Datum energy means potential energy. So what do you mean by potential energy? The energy of material because of its uh, because of its because of its nature or because of its position, that is known as a potential energy, because of its position. Okay, so position or configuration. So the energy of material because of its position or configuration is, that is nothing but the potential energy. And then what is meant by kinetic energy? Kinetic energy means energy of substance because of the motion, that is a kinetic energy. Okay, and pressure energy means because of the pressure. Okay? So these three energies, potential, pressure and kinetic energy, they will make a total energy of fluid at a particular point. So total energy per unit mass will be constant at any time, at any point. That is the Bernoulli's theorem. Okay, but यहाँ पे क्या हो रहा है कि so additional energy डाल रहा है, pump is putting additional energy. Okay? Pump is putting additional energy, and because of this because of flow through this pipe. So flow through this pipe during the when fluid is passing through this pipe, or when fluid is flowing through this pipe, so there is some loss in the energy. So they are known as energy losses. That is known as energy losses. So during the flow of fluid through the pipe, there is a loss of energy, that is known as energy losses. So now these energy losses may be of three types: frictional losses, then fitting losses. So we'll see that in upcoming slide. So first one is the application of Bernoulli's theorem. अभी Bernoulli's theorem देखा है आपने. क्या है कि Bernoulli's theorem बोलता है कि for a steady state flow of a fluid, ideal flow of fluid, the energy per unit mass will remain constant at any point. That is the Bernoulli's theorem. Now applications of Bernoulli's theorem. So it is applicable in the measurement of, it is useful in the measurement of flow rate of fluid using orifice meter and venturimeter. तो उसके ऊपर ये भी क्वेश्चन आ चुका है कि orifice meter and venturimeter, they are based on the Bernoulli's theorem. ऐसा एक क्वेश्चन आ चुका है. So याद रखो, Bernoulli's theorem is applicable for measurement of flow rate of fluid flow using orifice and venturimeter. Then it is also applied to working of centrifugal pumps. And there is another term known as a pressure head. Pressure head is dependent on the height of column in liquid with known density. Energy losses, इसमें fluid flow हो रहा है. So what kind of energy losses will be there? So as I have told you, there are three kind of energy losses: frictional losses. First one is the frictional losses. जो friction हो रहा है between the walls of pipe and the fluid. So due to that, some kinetic energy is utilized. That energy will be converted into heat energy. That is nothing but the frictional loss. Okay. So in that also, if you want to read more, you can read from books. But what is important? Types of losses is important, and the Hagen-Poiseuille equation. Hagen-Poiseuille equation, that is used for calculating the pressure drop due to friction. So वहाँ फ्रिक्शन की वजह से जो प्रेशर कम हो रहा है, प्रेशर ड्रॉप मतलब डिक्रीज इन द प्रेशर ड्यू टू फ्रिक्शन between the fluid and the wall of pipe. That also can be calculated by Hagen-Poiseuille's equation. Then again another equation is there known as a Fanning equation. Fanning equation. It is related to frictional losses in the fluid flow. Okay? Pressure drop due to the friction in the fluid is directly proportional to. अभी ये जो प्रेशर कम होता है ड्यू टू फ्रिक्शन ऑफ फ्लूइड एंड द वॉल ऑफ पाइप, उसके बीच में जो फ्रिक्शन हो रहा है उसकी वजह से जो प्रेशर कम हो रहा है, दैट इज अ प्रेशर ड्रॉप ड्यू टू फ्रिक्शन between the wall of the pipe and directly proportional to the viscosity of fluid. It is directly proportional to the viscosity of fluid, then density of fluid, then length of pipe. Okay? Viscosity of fluid, density of fluid, and length of pipe. So whatever frictional losses are there, it is directly proportional to the viscosity of fluid, density of fluid, and length of pipe, and inversely proportional to the pipe diameter. So जितना diameter कम होगा उतना frictional loss ज़्यादा होगा, जितना diameter ज़्यादा होगा frictional loss कम होगा. And another loss is there known as a fitting loss. तो जैसे आप पाइपलाइन में क्या होता है, जैसे पाइपलाइन है तो उसमें कहाँ कहाँ पे मोड़ना है तो वहाँ पे अपन एल्बो लगाएंगे, या फिर वो पाइपलाइन को आपको एक जगह एक दूसरी जगह पे ओपनिंग देना है वहाँ पे टी लगाएंगे. सो बिकॉज ऑफ दैट आल्सो losses, that is known as a fitting loss. Losses due to change in the direction of fluid flow. For example, आपको यू टर्न मारना है, आप क्या करेंगे वहाँ पे एल्बो लगा के फिटिंग कर देंगे. तो एल्बो लगाने के बाद में जो डायरेक्शन जो होता है फ्लूइड का, बिकॉज ऑफ दैट आल्सो देयर इज सम लॉस इन द एनर्जी. So losses due to changing in the direction of fluid flow, like due to fittings like elbow fittings, couplings, unions, and walls. So those kind of losses, they are fitting losses. And then enlargement losses. Third kind of loss is nothing but the enlargement loss. Energy losses during the flow of fluid through pipe. Frictional losses, fitting losses, and energy enlargement losses. Suppose that आपके एक वहाँ पे एक पाइप है और सडनली आपने वो पाइप बड़ा कर दिया, that is nothing but the enlargement. So sudden enlargement of diameter of pipe, that will also loss. So the enlargement losses, sudden enlargement of dimension of pipe. इसमें दो टाइप का होता है enlargement. तो enlargement losses और contraction losses. Contraction losses मतलब sudden contraction of diameter of your pipe. ठीक है, मान लीजिए कि यहाँ पे नॉर्मल पाइप है आपका, ये देखो ये नॉर्मल पाइप है, यहाँ पे सडन एनलार्जमेंट, ऐसा एनलार्जमेंट, यहाँ पे सडन कॉन्ट्रैक्शन मतलब ये देखो ये पाइप है नॉर्मल, सडन कॉन्ट्रैक्शन और सडन एनलार्जमेंट, that also causes losses in the energy, that is known as energy losses while flowing the fluid through pipe. They are nothing but the frictional losses, then fitting losses, and enlargement contraction losses. Okay, यहाँ पे याद रखो again Poiseuille's equation and the Fanning equation. These two equations are related with the energy losses in the fluid flow due to friction. ये क्या रखो, इसके ऊपर भी क्वेश्चन बन सकता है. Next point is measurement of flow of fluid. So how you can measure the flow of fluid. So there are different methods. First one is a direct weighing method. So measurement of flow of fluid. So method and example. Measurement method and example. So first one is a direct weighing or measuring. So how you can measure a direct the flow rate, कि किस रेट से फ्लो हो रहा है आपका लिक्विड, वो आप मेजर कैसे कर सकते हो. मान लीजिए कि आपने क्या किया, एक टंकी ले ली और आपके मोटर चालू किया, आपने मोटर चालू किया एक 5 मिनट के लिए से, और टंकी में पानी कलेक्ट किया. ओके, और वो पानी का वेट किया आपने. सो वेट फ्लो पर यूनिट टाइम, दैट इज नथिंग बट द रेट. सो यू कैन कैलकुलेट डिपेंडिंग ऑन द फ्लो पर यूनिट टाइम. तो आपके पास वेट आ गया वाटर का, 5 मिनट में अपने मोटर में कितना पानी आया 5 मिनट में, और टाइम कितना लगा 5 मिनट, तो उसके ऊपर मास अपॉन टाइम यू कैन कैलकुलेट द रेट. दैट इज द डायरेक्ट weighing or measuring. Then another method is there known as a hydrodynamic method. So in that you use different kind of meters, orifice meter, rotameter, venturimeter, etc. So orifice meter, venturimeter, and Whiter tube and rotameter. These are the methods used for measuring the rate of flow in a hydrodynamic condition. ठीक है, हाइड्रोडायनामिक कंडीशन में कौन से कैसे यूज कर सकते हो, कैसे रेट मेजर कर सकते हो, यूजिंग ओरिपीस मीटर, यूजिंग वेंचुरीमीटर, यूजिंग पाइटर ट्यूब एंड यूजिंग रोटामीटर. Direct displacement meter is also there, has certain advantage over orifice meter and venturimeter. Now hydrodynamic methods, उसमें हर एक मीटर के बारे में, इसका कंस्ट्रक्शन वर्किंग अलग अलग होता है हर एक का. तो यू कैन, इफ यू वांट टू रीड, यू कैन रीड द कंस्ट्रक्शन वर्किंग ऑफ ईच एंड एवरी meters, but that is not important for GPAT. What is important, whatever those points are I have listed over. So first one is a orifice meter. So इसमें क्या होता है, इसका कंस्ट्रक्शन होता है थिन प्लेट कंटेनिंग नैरो एंड शार्प अपर्चर, दैट इज अ ओरिफिस मीटर. इसके बारे में इसका डायग्राम आपको दिखा दूंगा. रिमेंबर, इट इज आल्सो नोन एज वेरिएबल हेड मीटर. Orifice meter is also known as a variable head meter, and again it is based upon the Bernoulli's theorem. Another hydrodynamic method, measurement of flow rate using hydrodynamic method, venturimeter. So in this construction is like this: two tapered sections in the pipeline with a gradual constriction that is known as throat at its center. So it is most commonly used for measuring the flow rate of liquid, that is venturimeter. Again, it is based upon the Bernoulli's theorem, and it is referred as a variable head meter. It is also referred as a variable head meter. दोनों भी orifice plus venturi. Third one is a pitot tube. So it consists of a sensing element with a small constriction compared to size of flow channel. मतलब पाइप के साइज से, उसका बाद में इसका डायग्राम दिखा दूंगा. So it is also known as a, remember, it is also known as इंसर्शन मीटर. ये पाइप के अंदर डालते हैं ना, इसलिए इसको इंसर्शन मीटर बोलते हैं. पाइटॉट ट्यूब measures the velocity at one point only. Then last one is the rotameter. So vertically tapered and transparent tube in which plummet is placed. So it is also known as area meter. Rotameter is also known as area meter, and it is used in the chemical industry for such as bulk drugs. वो वहाँ पे यूज करेंगे, measurement of flow of solvents and all that. Satisfactory with the gases as well as liquid at a high and low pressure. So if you want to introduce liquids and gases at a high pressure, low pressure, so rotameter is used to measure the flow rate. याद रखो कि to measure the flow rate, different methods are there: direct weighing measuring, hydrodynamic methods, and direct displacement methods. Out of that hydrodynamic methods में क्या है, ये सब है. These are all are the hydrodynamic methods: orifice meter, venturimeter, Pitot tube, and rotameters. These are the hydrodynamic methods for measuring the fluid rate, flow rate. Okay, so you can see over here, this is a orifice meter. तो ये आपका क्या है, ये पाइप होगा आपका, this is your pipe. So in this, then there is a contraction. Okay, here is a contraction. यहाँ पे देखो, यहाँ पे क्या है, नैरो हो गया है यहाँ पे ल्यूमेन पाइप. यहाँ पे अटैच करेंगे आपका मैनोमीटर. तो इट विल मेजर द प्रेशर डिफरेंशियल एट दिस. सो orifice प्लेट, यहाँ पे एक थोड़ा सा छोटा सा छेद रहेगा ना, इसलिए orifice मीटर. So if you want to read more about this construction and working, you can read from book. Then again, this second one is a venturimeter. Venturimeter, यहाँ पे क्या रहेगा, थ्रोट रहेगा. Then this one is a Pitot tube. Pitot tube जो है वो, that is a tangentially inserted into the pipe. Tangentially inserted into the pipe. So whatever pressure differential, pressure drop, ठीक है, यहाँ पे जो प्रेशर है ये पॉइंट पे, और यहाँ पे जो प्रेशर है ये पॉइंट पे, डिफरेंस होगा ना. तो यहाँ पे प्रेशर जो ये पॉइंट पे प्रेशर ज़्यादा होगा, बाद में कम होगा, बिकॉज ऑफ दैट इंसर्टेड Pitot tube. So it measures the pressure differential. So ये सिर्फ आपको उसके बाद में बारे में ज़्यादा चाहिए इंफॉर्मेशन, तो बाद में पढ़िए. So this was regarding the flow of fluid.